Hello friends, in today's class we will see synchronization hardware. Just now we have seen in previous classes or yesterday's class, whatever we had seen, it is a Peterson solution for critical section problem. Okay, this Peterson solution is a software based solution to this critical section problem. So any solution to this critical section problem needs one tool. That tool is lock. A process must acquire or it must get a lock before entering a critical section. So it releases that lock when it exits the critical section. This is shown in this figure. See, before going to entering into this critical section, the process should get or acquire that lock. After execution of critical section, when it wants to come out of this critical section, it has to release that lock and it starts continuing execution of remainder section. Okay, here the test and set instruction can be defined in this figure as shown in this figure. That is boolean test and set. How we are going to define this instruction, just see, it is a boolean type of instruction, the test and set. So boolean star target, it means target is a pointer variable which stores the address of another variable. So boolean rv is equal to star target and star target is equal to true. It means if a target value is true, then return that rv. Okay, so the important characteristic of this instruction is that it is executed atomically. Atomically means uninterruptibly. So continuously it, without any interruption, it executes. Therefore if two test and set instructions are executed simultaneously, then these two instructions will be executing on two different CPUs. Then they will be executed sequentially in some arbitrary order. If the machine supports that test and set instruction, then we can implement mutual exclusion by declaring a boolean variable lock, which is initialized to false. The structure of a process P is shown in this figure. See, this is a structure of figure, that is 2.12. so here mutual exclusion we are going to implement with the test and set instruction. Do while test and set ampersand lock, don't do anything and execute a critical section, and lock is equal to false. Then once the lock is false means, so critical section is executed, the process is executed critical section, and now it wants to come out of this critical section, so lock will be false. Then it starts continuing the execution of remainder section while true. Okay, the swap instruction, in opposite to this test and set instruction, operates on the contents of two words. It is defined as shown in this figure. So swap boolean pointer A, boolean pointer B. Boolean temp is equal to pointer A is equal to pointer B is equal to temp. So these are three steps for swapping. So here the swap instruction is going to operate on a contents of two words. It is defined in this figure, already I shown you. So like this test and set instruction, it is executed atomically, it means uninterruptible. So if the machine supports this swap instruction, then mutual exclusion can be provided as follows. A global boolean variable lock is declared and it is initialized to false. So initially the lock will be false. So in addition, each process has a local boolean variable key. Okay, the structure of a process P is shown in this figure. Okay, mutual exclusion implementation with the swap instruction is like this. So key is true, and while key is true, swap address of lock and address of key. So after swapping, execute the critical section, and once the execution of critical section is completed, then lock will become false. Okay, then execute the remainder section and while true. In next class we will see semaphores.